Hey class, so we're going to do section 6.4, which is using inverse functions. First thing before we get started on the actual problems, we need to know what the inverse is. The inverse is basically the opposite. So when we think about the opposite, we have these relations here that are just a list of ordered pairs. And so when we think about the opposite, we want to just switch them around. So we're switching the x and the y. So we end up with -3, 1. We end up with 3, -2. We end up with 1, 5, and 4, 6. Okay, so the inverse means the opposite. So that's what we're doing, the opposite. And you would do the same thing with number 2, just switching the x and the y values around. Now, moving to the actual problems that we have down here, it asks you to find an equation for the inverse of each of the following relations. So we have these equations down here, and the same way we did at the top where we switched the x and the y to find the inverse, we're going to switch the x and the y to find the inverse here, because that means the opposite. So in this case, instead of having y equals 3x plus 2, we're going to have x equals 3y plus 2. So when we switch it around, then we just solve for y. So we subtract 2 from both sides. That's going to cancel. I end up with x minus 2 is equal to 3y. Then I divide both sides by 3. And then I have y is equal to x minus 2 over 3. So that will be my final answer. So if you look at it, the original equation has y equals 3x, or multiplying x times 3, and then we're adding 2. And then the inverse actually has us subtracting 2 and dividing by 3. So that's the inverse. That's the opposite. So I'm going to go through and do number 7. Number 7, we have y equals 2 over 3x minus 5. So we're just going to, again, switch the x and the y. So we're going to have x is equal to 2 over 3y minus 5. Then we're going to just go ahead and solve for y. So I'm going to add 5 to both sides of the equation. And then we end up with x plus 5 is equal to 2 over 3y. Now with this 2 over 3y, we need to get rid of this fraction. How do we get rid of a fraction? Well, we do the reciprocal. So we multiply both sides by 3 over 2. And we're going to do the same thing to this side, multiply by 3 over 2. These are going to cancel, and so I'm left with just y on this side. And then I'm going to do distribute my 3 over 2. So I'm going to have 3 over 2x plus 15 over 2. So y equals 3 over 2x plus 15 over 2. The last example that I'm going to go through is number 11, because I'm pretty sure some of you all are looking at that square root like, oh my gosh, what am I supposed to do? Well, we do the same thing that we started with. We switch the x and the y. So we end up with x equals y squared plus 5. We do it the same way. Subtract 5 from both sides. That's going to cancel. I have x minus 5 is equal to y squared. Now, what's the opposite of a radical? What's the opposite of an exponent? It's a radical. So I'm going to take the square root of both sides. These two cancel each other out, so I'm left with y on the right side. And then I have the square root of x minus 5. So don't be scared of it just because you see a radical. So that's how we do each of these problems. So if I go to the next page, I have inverse functions. Again, but this one is actually, we're trying to figure out if these two given functions are inverses. So the way we do that is we use the property of inverse functions. So inverse function says that f of g of x is x and g of f of x is x. So if these two functions are inverses of each other, when we do the composition f of g of x and we have to do g of f of x, we have to do both, then they are inverses of each other. Now, function g, if it is an inverse, you're going to see the notation that looks like this. Okay? So don't say f to the negative 1. It's actually, you're supposed to say f inverse. So when you see that notation written like this, that means that we're talking about the inverse. So for number 7, it says state if the given functions are inverses. So the first thing that we're going to do is we're going to compose and do f of g of x. So everywhere I see x, I'm going to put the x plus 4 in. So I actually end up with x plus 4, because that was my f of x. That was my g of x minus 4. So the only thing I can do here is really combine like terms. So if I combine 4 and negative 4, I'm left with just x. So actually we met our first condition where f of g of x is x. So that checks out. So we have to make sure that we check and do the g of f of x. We have to make sure that it works both ways. So we need to do g of f of x. So g of f of x, we're going to do the opposite now. And everywhere we see x, we're going to put x minus 4. So now we end up with x minus 4 plus 4. So here, the only thing that we can do to simplify is combine the like terms, which is negative 4 and 4. So we end up with just x. So yes, g of f of x equals x. So then our second condition is met. So once we meet both conditions, state if the given functions are inverses. Yes, they are inverses. They're inverses because we ended up with f of g of x like up here being x, and then we ended up with g of f of x being x. Okay, so I'm going to do one more example of this one. So we're going to do f of g of x here. So everywhere in this function where I see x, I'm going to put 2x minus 1. So I end up with negative 4 plus 2 over 3 times negative 2x minus 1. So with that, we just simplify as much as we possibly can. So we have negative 4 plus 2, excuse me, did it multiply? Let's go back. All right, plus, or minus actually, negative 4 over 3x minus 1. 2 over 3. Okay, I'm going to do my side work over here, do my little formula, and I'm going to have negative 4 over 1 minus 2 over 3. So we end up with negative 12 minus 3 over 1, which ends up being negative, over 3, which ends up being, I'm so sorry, negative 12 minus 2. So we end up with negative 14 over 3. So our f of g of x ends up being negative 4 over 3x minus 14 over 3. This clearly is not x. There's nothing else I can do to simplify this. So that means that no, they are not inverses of each other. And we do the same thing for 9, 10, 11, and 12. The last thing we have is the horizontal line test. The horizontal line test is exactly the opposite of the vertical line test. So vertical line test is used to tell whether or not a function is, whether a graph is a function. So now, since a horizontal line is the inverse of a vertical line, we're using the horizontal line test to see if the inverse of this graph is a function. So if a horizontal line passes through 2 or more points of the graph f of x as a function of x, the f of x will not have an inverse function for the given domain. So I have this graph here. This graph is the graph of y equals x to the third power over 5. So I have this vertical line. Actually, let me highlight it for you because it is a little difficult to see. So this is my vertical line. My vertical line here touches my graph, which this is my graph, it only touches it in one spot, which is there. And no matter where, if I were to move the vertical line up or if I were to move the vertical line down, it's still only going to touch it in one spot. So that's why it says, yes, it will have an inverse function. Okay? Now, if I look at the second one, which is y equals x squared plus 1, and since it's the second power, it's a parabola, then I do my vertical line test. It actually touches the vertical line at 2 different points. So because it touches it at 2 different points, it is not going to have an inverse function. So what you guys are going to do at the bottom here is you're going to graph the function and you're going to graph the function and use the graph to determine whether or not the inverse of f is a function. So what you're going to do is you're going to take your graphing calculator, and yes, it's on my phone. It's going to be y equals, and we're doing 3x plus 1. 3x plus 1. And we're going to graph it. And so when we graph it, we end up with this line. With this line, if I have a vertical line, no matter where I put it, it's only ever going to cross at one spot. So once we graph the function, just kind of sketch it right here so you know what it is supposed to look like. It doesn't have to be great. Like that's all I'm really asking for. So to determine whether or not the inverse is a function, so we would say the inverse is a function. And you're going to continue to do that for all the other problems. The other one that I want to do with you is letter H, because I'm not sure if you all know how to graph the absolute value. So we go back to y equals and press clear. And then we're going to press second. Let me see that. Oh, let's go back down. All right, there we go. We go back to y equals, press second. And then down here at the bottom where you have the 0 button, you're going to press catalog. When you see catalog, you see ABS at the top. So ABS means absolute value. Press enter. Some of your actual equations, some of your calculators are going to give you the absolute value brackets, and some of them are not. So with this one, it does not, but either way, we're going to put x. So find the absolute value of x plus 4, and then we graph it. And of course, the absolute value looks like a V. So I'm drawing my V down here, and if I do the horizontal line test, it's clearly going to touch the line at more than 1 point. And look at it down here. It definitely is going to touch it at more than 1 point. So then this one, we would say the inverse is not a function. Okay, I hope this helps, and I will see you guys when I return from Virginia Beach. Have an awesome weekend.